We are in step 14 already, and what we have to have in advance here is a folder that I call workspace for predictions. And in here, you need 3 more folders. One is the folder for your predictions, so the final predictions will be created in here, will be generated in here. Another folder should be called models, and in there you should have the folder with your own start-this network. All right, so this is my start-this network. You should be familiar with that if you've trained the network in start-this. But that's the structure as it should be. And then one more folder which I called white BG, and it's practically nothing more than this folder which I copied and pasted in there. It's exactly the same. It's the white background images that we produced, and we're using white background images because any related contour related false positives of start-this will be at the outer part of the segmented area. So imagine that you have this image but with the white background, and you have let me see if I can zoom, and you have false positives across the contours, right? The benefit of having a white background is that the mispredictions due to the contours will be at the outer part almost entirely, if not entirely. And then it's very easy to remove them because they have a specific pixel value that we can use as model value. So that's the idea. Sometimes it has only happened once to us, but it is possible that the white background will create problems which you will not encounter with the black background. Keep that in mind. You might want to switch to black background if that doesn't work. And you already have these resized images. This is the step just before you turn them to white background, which you can use. But I would strongly recommend going for the white background. So after you've done that, after you've created these folders here, then you just open your script. Okay. Now that I have opened it, I have to select the kernel. For the rest of the kernels, most likely by the end of this video series, I will have you one particular environment with all libraries in there for you to run. But unfortunately for the start-this, sometimes it gets quite tricky with the installation, the TensorFlow, the Python versions and everything. And it was quite costly in terms of time to me to put it in the environment again. So you will have to load the environment here after you install it, of course, and there will be instructions for that in another video. So Python environments, we go, and you have to search for start-this predictions, predict. If you cannot find it, then do something like, start typing and it might appear. Okay, now we have it. Now that we have it, we start running the codes. And the libraries should be imported soon, yes. All right, so next step is that you want to define the directory where your code is taking place actually in here. And it's the same name as you can see, right, and the same path. So it's on my desktop and it's this folder. After that, you want to make sure that the folder, the subfolder, which is located inside your workspace for predictions, the name of the subfolder is pasted here. This is the name in this case. Now, keep an eye on that. There are TIFF files with one F and TIFF files with two Fs. Why? We will never know, I guess. But if you have a TIFF with two Fs, then you will get a list index out of range error. And if you change it to two Fs, provided that you have two Fs in your format, in your files, it will run properly. Then what you should take into account is that the product of these two numbers should be at least equal to the number of images that you have. All right, so I'm going to white background image, and you see that I have 56 items. So 7 times 8 is 56. So that's the multiplication product. And for the figure size, I don't know if it matters, but what I know for sure is that sometimes our kernel dies when we run this kind of analysis. And I suspect that it has to do something with the memory. So I just reduce the figure size every time in case it alleviates, in a sense, anything related to the RAM. I really don't have any idea how this really works, but I'm just trying to make it, less heavy computationally, although it might not be just by increasing the figure size. That's for those who know better than me. All right, so I've set the figure size at 8 times 8. These numbers here is just for visualization. You can, if you want, you can completely remove all this part and the code will still run fine. All right, so don't mind about that. So right now I can start running my script. So in the meantime, what I can do is make sure that at the next cell I have everything placed properly. So the base directory is the models, and indeed in here you can see the models directory, and in there you want the name of your network to be, which is here in this case too. Okay, the previous cell now has run, and this is just a visualization, but you need to run this because variables created here are essential for the code later on to run. Okay, so now that I run this cell as well, I get these values, which are the recommended values based on my network. And it's probably the threshold of 0.55 almost. And if I'm not mistaken, maybe I'm mistaken here, but I think this has to do with the accepted overlap between two objects and how easy it is to uh, separate them. But I might be mistaken here. It's been some time. You can search that in the documentation for sure. Okay, moving forward now, the network is already loaded, so now we just have to run it. Again, I'm superstitious and not very aware of how things really computationally work here, so I just reduce the figure size to 8 and 8. Uh, what I want to do next is that I want to locate the path of the directory that has the images inside, all right? And it's this one. So if you see that path, it's practically this path. So that's good. And keep an eye on that if again here. And then I'm going to the predictions, which is where I want my predictions to be actually generated in. And I want them to be in this folder. So this path corresponds to this path here. So everything is ready to run in principle. Let's just reduce the font size here. There's no reason to have it bigger. And I start running. So sometimes here the whole code runs smoothly. Other times the kernel dies somewhere in the middle of the procedure. What you can do about it is just separate your files in different folders and continue from where you stopped. So assuming that you will produce, I don't know, predictions for these images, right? And you stop here, you will be able to see what was the last file that you stopped at because you will be able to see the numbers of your IDs. I always delete the last one because I don't know if it's created properly. And then I create another folder which you can name whitebg1, for example, and another folder called predictions1. And then I rerun the code and make sure I change the paths. And at the end, I want to gather all predictions to one file. For now, it's working okay. And it will probably run okay because I've run this dataset. But yeah, I'm gonna stop the video now and I will show you how the results look like.